Everybody, loving the really technical questions that you got there, Piers. I'm hoping that I get an easier ride. A lot of the stuff that I'm going to talk about is all stuff that I have learned since being at Purcell for the last 3 years, and I work with some very clever and experienced people who kind of do all the background stuff. I get to tell the stories, which is really nice. I am an architect by background, but my role is head of sustainability. So I'm maybe an architect in recovery, perhaps, but still have lots of opinions about architecture, obviously. For those who don't know about Purcell, we're about 350 people, spread across 14 studios in the UK and in Asia Pacific. We have had the privilege of working on some of the most recognizable buildings in the world. And we span lots of different sectors as well. And I think it probably goes without saying, none of our projects are the same. Every single historic building is unique, even if from the outside it looks like a very repetitive street of terrace houses. Every single one will have been adapted differently, altered slightly differently, sometimes for the worse. And yeah, so we're always kind of discovering, I think it's fair to say. This year, we celebrated getting B Corp certification, which is something that we're really proud of, but we do see it very much as the beginning of our journey towards better environmental and social responsibility. And I think that that's probably enough of an introduction to Purcell. So I'm here to talk about heritage and climate and heritage retrofit. And I think one of the things that I enjoy most about my job is that I always thought heritage was about the past and kind of thinking about the past. And sustainability is very much thinking about the future. And there is a tension there, but I think what I've learned from working with so many heritage professionals is that actually preserving our built heritage and telling the stories of our past is very much future focused. We're doing it with a mind to make sure that those stories are told going forward and are available to future generations. And really, conservation is about preserving our inherited world for future generations. And I think that that is inherently linked to sustainability and planetary health. So why care about heritage? I will just check why I thought that this slide was important. So I think it's about how we tell the stories of our past, how we've evolved and adapted our environments to suit changing needs. Really, it's kind of the visual catalogue of human ingenuity over the centuries. And for those of you, I'm sure everybody in the room is familiar with the listed system that we have in this country, which has grade 1, 2, and then grade 1, 2-star, and 2, 1 being the most significant. And grade 1 makes up about 2.5% of the listed buildings. Grade 2-star makes up about 5.5% of listed buildings. And then grade 2 is the bulk of listed buildings, about 92%. And when we talk about heritage, we talk about significance and why places are of significance. And we measure it in values. Heritage value, which is about learning things about how the people used to live in the past, and how we connect through place to the present. Aesthetic value, which is about the values that are drawn from sensory and intellectual stimulation from a place. Evidential value, so what can that place inform us about how we used to live and past human activity. And then communal value, which is about that kind of collective experience and coming together collectively as a memory of place. And I'm explaining these here because this is really important to how you build a case for change in heritage buildings. It's not, in order to be able to change a historic building, you need to be able to understand what's important about it and why it is protected. And so heritage is all inherited resources which people value for reasons beyond mere utility. And really, I think we place values on our heritage buildings because we see that they're important culturally to us, and we have listed status and we place restrictions on them, and we measure value in a way that goes beyond monetary value. And I think that, to me, is a really important lesson that we can take from heritage into the wider built environment. It's You know, we're kind of reaching out there with social value more and more, but I think what heritage does is really quantify why place is important in a way that transcends monetary value. And then the conservation of heritage is often seen as a barrier to change. And I think some of you in the room might own listed buildings or occupy listed buildings and may have stories of how challenging it is to adapt and alter them and the kind of the processes that you have to go through. And so it's often seen as, particularly in retrofit terms and energy efficiency measures, is often seen as a barrier. So the actual definition of conservation is the protection of plants and animals, natural areas, and interesting and important structures and buildings, especially from the damaging effects of human activity. And to me, that is inextricably linked with planetary health and the kind of environmental sustainability goals. And we've all been in places, we've lived in places, we've probably worked in places, visited places that have adapted over time and are a different use to where they used to be, to what they were intended. And I think the idea that listed buildings can't change isn't true, because historic buildings have always changed for as long as we've built buildings. And this is a study, a really interesting report that was brought out in 2023 on the heritage and carbon skills gap. And it kind of quantifies the number of heritage buildings, or at least traditionally constructed buildings, so buildings that were built before 1919. And I've got the stats somewhere. So 2.5 million homes and 600,000 historic commercial properties. And as a quantum, they kind of quantified the amount of carbon that could be saved if all of those buildings were retrofitted. And so I think what it hammers home is that it's not an area of our built environment that we can ignore. It's not something that we can kind of just say, oh, it's too difficult. Let's take the easy wins. We can't not address heritage when it comes to carbon emissions. And obviously, it's not just about carbon. There's lots of other benefits as well to retrofitting heritage. So reduced energy costs being hopefully an obvious one. Energy security, comfortable and healthy internal environments, resilience against future climate change and uncertainty. Obviously, the conservation of natural resources because you're reusing existing buildings, increasing market value and avoiding stranded assets. And then if you're an owner and you're trying to attract climate conscious clientele, workforce, deliver on green commitments, obviously you will have commitments that you need to try and address. And it's important that heritage doesn't get left out of that equation and become obsolete, because it's not able to keep up the same level of energy efficiency and carbon reduction as other non-listed buildings. And so this slide is just to kind of describe a little bit. This is a drawing that I use all the time from Historic England, which really helpfully kind of distinguishes the difference between how we build now and how we used to build in the past. And so before about 1919, buildings were traditionally constructed with solid masonry walls. They were made out of materials that predate kind of cement, like modern cement. And so they're made out of vapor permeable materials, so they kind of absorb moisture from the surroundings and then release it depending on the climatic conditions, both internally and externally. And there's lots of air movement, and that's how they deal with moisture. In new buildings, as we've just seen very comprehensively, they're very impermeable to moisture. They are very sealed, and you have to ventilate through opening windows or through ventilation systems. So the challenge in historic buildings is if you introduce new materials that aren't the same properties, so don't have the same vapor permeability, then you will risk moisture accumulation, condensation, mold, and poor indoor environmental quality. And the other thing to consider, and this is true of any building, that a building is a system, so there's lots of interconnected components, people, services that all interact with each other. So if you change one of those components without considering how it connects to other things, you'll have a potentially negative knock-on effect to something else. So for example, that if you seal up all of the windows, insulate, and you've increased the air tightness of a building without thinking about ventilation, you will have unintended consequences. And so in heritage, it's always about getting a balance right. It's always about measuring the harm versus the benefit. And there's always going to be compromise. I think there isn't any project on new build or retrofit that doesn't involve compromise. So I think it's just about how you tell those stories and how you get the best outcome for the building and the occupants. And obviously, you all know already the AECB resources, so I haven't got those on here, but there's a few others that might be useful. So there's the PASS 2035, which is for retrofitting housing, PASS 2038, which is for retrofitting non-domestic buildings. Both have a kind of quite clear process of how you go through things, and it does have a kind of add on to how you deal with that in heritage properties. The STBA has this amazing wheel which just kind of defines like that system, the building as a system approach. So you click on one element and it kind of tells you through these linked diagrams what the knock-on effects of changing that would be. It's a really good interactive tool, I recommend it. And then last year, Historic England brought out this adapting historic buildings for energy and carbon efficiency. Historic England have been really trying to help with these kind of conversations. I think they don't want to be seen to be lagging behind the narrative on climate change. So they are spending quite a lot of resources and energy in this space. So that is another one that is good to have a look at. We also have our own toolkit, which we developed with City of London. So I'm going to talk through that briefly. But this started out because City of London has got a net zero target of 2040 across the entire square mile. So for anyone who doesn't know, City Corporation is the kind of local authority that governs the square mile. And if you've not been, the square mile is made up of 600 listed buildings. None of them are the same. It's a complete smorgasbord of history, which is amazing, but does make it quite challenging when you're trying to get to net zero by 2040. So they identified that actually tackling historic buildings would be a really key step in their net zero journey. And so they employed Purcell to do a series of stakeholder engagements, and we talked to owners and occupiers of listed buildings across the square mile and asked them a number of questions. So where are we now? What kind of opportunities have people already taken to reduce their carbon? What do people need? What's kind of missing, and what are the key complexities? And unsurprisingly, the barriers to climate action in heritage kind of cloud mapped on the wall, but cost being the most consistent message. Complexity, obviously, I think lack of skills and not just lack of understanding of where to start. So we went away and talked with the city about how we could help with this process. And we developed a toolkit, which has this 9-step approach for how you'd go about a heritage retrofit project to reduce carbon and build climate resilience. And I'm not going to go through every step, so I recommend you all go and seek it out if you're interested. But it identifies 8 typologies across the city, so it is city specific, but at the same time, there are kind of, the approach will be the same in any historic building, in theory. So I'm going to take through in more detail the first 3 along there. It does go into a little bit more detail about developing a whole building retrofit plan, a lot of which is very common with guides like Letty, if you're familiar with the retrofit guides from Letty. And building a business case was obviously a really, really important one for any building owner, because it is hugely challenging to pay for all of this. But the first step is about starting from a position of knowledge. And this sounds obvious, but I don't think it's necessarily always applicable. And I think particularly on heritage buildings, the most important thing to start with is an understanding of that significance of your building, why it's important, what is special about it, and why do people value it. And then kind of layer that with a deep understanding of the building's performance, its condition, how it's serviced, how much energy it's using, all of those kind of things, and kind of start building a picture of why it needs to change and how you might do that. And the city was really keen that we had quite upfront in the process, this identification of climate risks. They've spent quite a lot of resource and time looking into climate resilience in the city. They've identified 6 key hazards. Most significant to historic buildings would be overheating and flood risk. And they wanted to make sure that that was kind of considered as part of this early process. And really that's just, it's to avoid abortive work. If you're doing something now that has to last for 30 years, the climate's not going to be the same in the next 10 years. We already know from this year. So I think having that kind of future-focused process early on is really important to them. And what we found when we mapped out a lot of, I don't know if you can see, it's quite small, the 6 different hazards that the city had identified, we mapped out the kind of what the different mitigation measures might be in historic buildings, and what we found, there's loads of overlap, actually. So, and the one right in the middle that spans all of them is just keeping your building in a good state of repair and having frequent maintenance plans, carrying out inspections of your gutters and things like that, making sure your building's not damp. All of those things really help, and also help to reduce energy. The other thing when identifying risks is kind of what I touched on earlier around the differences between new modern methods of construction and traditional methods of construction, and that potential for maladaptation, the potential for changing something with unintended consequences. And that includes kind of potentially damaging heritage and historic fabric, but also the kind of indoor air quality and things, and understanding the interconnected links between those. And I will credit, so this diagram I redrew just for the graphic style, but I would credit Letty because this was largely learned from them. And then the third step is about evaluating opportunities, and I'm always for putting everything on the table and then taking things off when you're told to. And I don't believe that there's ever an argument of you can't do anything. I think there's always something to do. And I think this hierarchy kind of helps you think through that process. So we've talked a little bit about knowledge and kind of starting from a deep understanding of the site. But the first step after that is around eliminating unnecessary energy and resource wastage. So do you have gaps and cracks? Do you have windows that aren't sealed properly? Do you have spaces that are being heated but not used? Do you have occupants that just leave the doors open or leave the windows open in cold weather? It's kind of really looking at how the building is being used and what condition it's in. Then it's about kind of mitigating the impact of unavoidable energy and resource use. And that's more around kind of what easy wins, what lower hanging fruit can you do that will just kind of, LED lighting being the obvious one. You'd be surprised how many historic buildings don't have LED lighting. Energy efficiency appliances, efficient use of space, zoning. Can you change the controls easily to just zone things differently? Turn your thermostat down 1 degree. Those kind of things. Then, before looking at kind of improved performance of existing building fabric, which would be, particularly in heritage settings, a more intrusive opportunity. So those kind of insulation, air tightness, upgrades to windows and doors. And then it's not the last step because it's the least important. It's the last step because by the time you get to it, hopefully you've reduced your energy use. So your interventions, your active interventions, your mechanical systems that you're integrating won't need to be as big or energy intensive because you've reduced your energy use. So I'm going to talk a little bit about a couple of examples in practice that we've got. I've got loads, but I've selected a few, and I've got more at the back end of the presentation if there's questions and there's other things that you want me to talk about. The first one I'm going to talk about is St John's College, Cambridge. I'm just going to find my notes again. Just so I credit people properly. So we collaborated with MCW architects on this one, and we were conservation architects and heritage consultants. So there's a kind of one half is the new build, which MCW were leading, and then the retrofit of the heritage grade 1 listed 14th century court building was led by us. So this was the refurbishment of their junior common room, which is in the corner you can see on the plan, the yellow space there, and it's only a ground floor as well. So it was a very isolated part of the college. The college had declared a climate emergency, had set a brief to be as sustainable as possible, but without really giving any meaning as to what that was. So it was down to the team to interpret that, and the team chose to really push it as far as they could. And following that process, that kind of starting from a position of knowledge, the first thing, I'm going to start with the bottom right-hand image. That is a significance plan, and is a really common way of depicting in heritage how significant different parts of your building are. Just because it's grade 1 listed doesn't mean that everything is the same age, doesn't mean that it hasn't changed over time. And what you can see from this is that the very high, the kind of red areas, apologies for anyone who's colorblind, these drawings are not helpful for you, but you could take my word for it. So the very high being red, going down, and then the low significance, you can see kind of like the floors, some of the internal partitions, because they've been changed over time, they've been altered. So here actually a kind of newer concrete slab had been poured on the ground floor. There had been lots of changes to the internal partitions. There's timber paneling to the inside face of the rooms, which they kind of did a huge gazetteer of information about it from the archives of the college, just to kind of prove that things had been moved around, things weren't always as they'd originally been built. And then layered on top of that, there was a lot of investigation into the performance of the existing building. So you can see some thermal imaging shots there, just showing how the kind of drafts, heat loss through the windows. There was some U-value calculations done. I'll tell you the U-value test ranged between 2.38 and 0.35 on the external walls. So, and that was on the same wall. So there's no consistency whatsoever. There was an air permeability test done, and that got 28. So you can see when you're trying to get to the standards that are set by AECB, it's just not, you've got a long way to go. But all of that kind of backs up the MEP consultants, KJ Tate, and they did a lot of modelling with IES, and we developed 6 different options. Model 1 was the existing option around various levels of intervention. And really what this kind of, I'm not going to go into the detail of all of it, but Model 4 was just deemed to be the most, it saved the most energy, saved the most carbon, but with the least seemingly drastic intervention to the historic fabric. And the only difference between that one and the one that was the most energy saving and most carbon reducing was the glazing, which I'll come back onto. So we did, you can see here, this is grade 1 listed building. You can see the level of intervention that was carried out. So the whole floor was taken up and put foam glass insulation down and limecrete slab. And then there was wood wall insulation put onto the internal face of the external walls. There was soffit insulation. And I think this just kind of shows that you have to break eggs to make an omelette, whatever that saying is. You can't, it ended up being quite significant interventions in this very sensitive setting. And the windows was an interesting debate. It always is. I'm sure some of you might have stories of windows, window replacements, or trying to get rid of window replacements in historic buildings. We settled on a histoglass, which is a kind of thermally enhanced, better performing than what was already there. We kept the existing frames. We did do a mock-up of a slimline double glazing unit using the same materials, but the conservation officer and Historic England had concern about how that would look in the court, because we were only changing 4 of the windows in that court and how it looked as a collective. Whether you agree with that or not, as an approach, that's one that they took. And so the next project, sorry, I should say that the kind of interventions, I think it's on here. I think so the interventions that were selected achieved a 39% reduction in energy use and peak heat demand. So it's significant. And I think the windows were seen as because they're so small in relation to the overall elevation, actually insulating the external walls had a bigger impact than changing the windows. Smithton School, it's a completely different building. And I'm really excited I get to talk about this because we've just got planning for it and I wasn't allowed to talk about it before. So I have some Smithton School facts. I don't know if anybody knows who these two are. Alison and Peter Smithson. So Smithton School is one of the country's most significant modernist buildings and designed by Alison and Peter Smithson. It was completed in 1954. It's grade 2 star, so it's in that top 10 of the all listed buildings in England. And it was considered like a really radical approach to steel and glass. It's very modernist. And it's been used as a school for 70 years. So like most modernist buildings, they weren't designed for climate change. It's a one big thermal bridge. It's like, it is single glazing, it's got steel sticking out, it's no insulation whatsoever. And it's grade 2 star listed. So in theory, it is an incredibly difficult building to change and alter. And however, as a school, it doesn't function because it's too hot in the summer, it's too cold in the winter. There's issues with glare, overheat, like they are on the verge of moving out as a school. It's a public school, sorry. Yeah. And so it's quite clear that a wholesale like refurbishment of this building is needed to keep it functioning as a school. And one of the things about heritage significance, I think, use is so often connected to what is significant about a building. So being able to preserve the originally intended use is seen as a benefit. And if you're not able to retrofit and make the alterations to this to enable it to function as a school, you're losing that use. I don't know who would want to work in this space, and you're then risking the kind of future deterioration of this this piece of architectural heritage. So you can see, I'll go back to this one because you can see in the bottom right the kind of condition that it's in. That's not even the worst picture. The condensation has really corroded a lot of the windows and a lot of the steel, the reinforcements in the concrete, the precast concrete. So there's huge issues with defects. So it's quite clear, this is the kind of 3D version of that significance plan that I showed you for the other project. And the reason it's a 3D version is because you can't think about the significance of this building in plan form. It was quite clear to our heritage consultants that the way to understand the significance of this building, you're not considering how old the fabric is because it's 70 years old, it's not that old. But what is important about this building and why it's listed is the architectural composition of it and the steel frame. And what the team, the Purcell team did, we should say we're working with Jessica Wiles on this as well, and Arup. But what the Purcell team did was a condition survey, which went round and documented every single window on site and determined, actually that's the wrong one, this is this one I wanted, determined how things had changed, what condition they were in. So this one is showing, for those of you who aren't colourblind, again, I'm sorry, the green is the original glass. So much of that building has already changed. And so you're not preserving something that is old. You're not preserving something that's original. You're preserving a framed building and the composition that has as a piece of architecture and its use as a school. So this is the significance drawing that kind of shows that the red is depicting the kind of structural frame is of very high significance. The blue windows, the roof covering is very neutral in terms of significance. So it's not really having any impact on the significance because they've changed it so much. And so what that framing allowed us to do was to justify some complete wholesale changes to the fabric of a grade 2 star listed building. And so we're insulating, we're changing the windows, we're having thermally broken. Also, there's some, I haven't got the drawings here, but in the design and access statement, there's lots of different iterations of breaking the structural frame because the frame was part of, the window frame was part of this structural frame. So it was all connected and a huge coal bridge. It's probably better shown in this one. But how that gets detailed and things has already been very well thought out just at planning stage. And if you went through the design and access statement, there's a huge amount of detailed drawings for a planning application. And the reason that this has been approved planning is because we took Historic England, 20th Century Society, Conservation Officer, on that journey all the way through and explain to them what is important about this building, why it's important that it gets retained and used as a school, and how the design of the building is having a detrimental effect on its ability to last any longer. So it's watch this space. It's hopefully going to be on site quite soon. I'll whiz through a couple more. I've not got that many. And then there's time for questions before coffee. So Lesson Hall is in Yorkshire. This was a big residential hall, which was on the Heritage at Risk register, and because there had been a fire, there was a lot of damage. And this is the first residential building, Grade 1 listed building, where we put in double glazing. And again, that was through a really thorough investigation of every single window on site, what was important about it. We got the glazing specialist in to kind of try and date all of the different windows and help make the justification for why we could change some. They wouldn't let us change all of them. So it was very much a kind of piecemeal approach, again, coming back to that compromise. But it has had a fundamental impact on the kind of comfort of the spaces internally. Salford Cathedral is a really exciting one because Salford Cathedral want to be the greenest cathedral in England. They're very competitive. And they would need to do a huge amount of fabric upgrades. And they've invested a lot of time and energy into how they might decarbonise. And you kind of think of it's a challenging building to address. So because the roof was coming off, the roof come to the end of its life, we're putting on, it's already gone on, insulating the roof. The floor came up, there's insulation under the floor with underfloor heating. But the more interesting thing, looping back around to windows really, is that the stained glass all had to come out. It had lots of gaps, it was kind of in poor condition. So it all had to come off. And what we've done is move it inward so that we could get secondary glazing on the external face. And that, previously to this intervention, that, you know, when sometimes you see churches have got the grating on the outside to protect the stained glass from vandalism, this has kind of removed the need for that as well. So you're getting heritage benefits actually, because you can better see the stained glass from outside. And we got some help from University of Manchester, who did some life cycle assessments on the windows and kind of looked through the secondary glazing specifically, because they found it quite interesting. And we were kind of interested to know whether or not it was worth it. And actually the energy that's being saved because of that one intervention, the carbon that it cost to put in the secondary glazing is kind of paid back in less than a year and a half. So I think that's quite a good advert for considering it. And then this is the last one I wanted to talk about, just because the ones I've talked about so far are all big, very significant, not really scalable, maybe, solutions. And this is a project that we're working on which probably has the most scalability, and that's because of the approach. So this is there's 60 Grade 2 listed railway cottages in Crewe. In Crewe, we're working with Cheshire East Council, and they wanted to come up with an approach to these houses because they are quite repetitive. And we're working with Historic England to draw up a local listed building consent order, which, for those of you who don't know, one of the probably most prominent examples of this is in Royal Borough of Kensington and Chelsea. They did a LLBC for solar panels to Grade 2 listed buildings. So you can essentially install solar panels on your Grade 2 listed property in Kensington if you follow their kind of guidelines without getting listed building consent. So you're it's taking out that administrative burden, both on the homeowner and on the local authority. And so we're going through a similar process, but with not just with individual components, but on a kind of whole life retrofit approach. And we've got a number of different, I haven't got it all here. We've got a number of different, like a bronze, silver and gold approach to the retrofit of these homes, which are all being looked upon favourably by local authority, conservation officers and Historic England. So it's a good kind of mechanism for scaling. And really this is just to kind of sum up. So start from a position of knowledge. hopefully that's kind of been hammered home. Understand the significance, ideally with heritage consultants or conservation architects if you can. Regularly engage with statutory consultees, so engage Historic England and local conservation officer and any other interest groups. Take a whole building approach and try and make the biggest improvements in the areas of the least significance when you have that understanding. And we talked about use of building and continuing the use and enjoyment of these buildings for future generations being at the heart of all of this kind of work. And yeah, that's, oh, I have got a quote at the end. Oh no, I've just lost it. There we go. This is from Society of Protection of Ancient Buildings. So just to kind of, again, reiterate the inherent link between conservation and climate action.